take a look at this small simulation here, right? No, now just take a look at it. I see the one I was spent too long looking at. Right. What are we looking at now? Always see in your notes, right? Always see in your notes, right? So sometimes you might have a particle, right? But the particle is excited. What does that mean? What does an excited particle mean? Okay. Right, right? And not just a lot of energy, it has too much energy, right? And of course, particles can't stay like this for long. So to go from excited to stable, what do you think will happen? To go from excited to stable, what must happen? Lose energy, right? So what will happen is that it will lose energy. Right? I'll look for this simulation just now, but it shows the same thing. It will lose energy. And the type of particle that we're looking at radioactive nuclei. Right? So when it loses energy, it's going to lose the energy in the form of radiation. Right? So it's going to lose its energy in the form of radiation. And the radiation, right? The radiation that we have to learn are 3 types. Right? You're going to lose 3 types of radiation. The first one is alpha. Anybody remember what that is from last week? What's the alpha particle? A helium atom. Remember from last week? The thing that hit the cold foil? Yeah? That was alpha. Right? So the first type of radiation, alpha. What is alpha? Alpha is a helium atom. Right? A helium atom. The next type of radiation is what we call a beta particle. A beta particle is an electron. Okay? And last one is a alpha, beta, and what? And what? No, gamma. What are we for? Alpha, beta, gamma. All here? All right, anyway, gamma. Right, gamma is not a particle, gamma is a ray. So this is just energy. Right, like gamma rays, those are just energy. So when an excited particle, right, when an excited particle loses the energy to become a stable particle, it's going to lose the energy in the form of radiation. And the 3 types of radiation we need to learn about are alpha, beta, gamma. That's okay? Alpha is simply a helium atom. Beta, an electron. Gamma is energy. All right? So, you want to catch this, and then we're going to talk about each one. Right? We're going to talk about each one of these. All right, so we're going to focus now on radiation, right? So last week we did the physics of the atom. We looked at the how the atom was produced. You all looked at the Thomson experiment, right? No? Andalo algo sa'yo uno. Which one? Stable, sorry, stable. Right? When you go from excited to stable, you lose the energy. About stable. Higher. Radioactive nuclei. Radioactive nuclei. I should put nucleus because it's just one, right? Right. Online, right? So I send this in, I send this handout in group, right? So you all do after, right? Right. Let's just take a look at okay, something I forgot to mention last week is isotopes. Right? I forgot to mention isotopes. If you're not in the group as yet, you are correct. I just that's right there. Right, yeah. The first part of this physics of the atom is just chemistry. All right, you ready? Ready? So let's take a look. Oh, I forgot to mention this last week. Isotopes are what? Isotopes have the same what? Atomic number but different mass number, right? So I forgot to mention that last week. Same atomic number, different mass number, right? Okay. So the focus is here. We want to focus on radioactive emissions and these three types of radiation, right? Right? So we have what's in notes, right? So you have three types of radiation, alpha, beta, and gamma. It said alpha is what? Alpha is a helium atom, beta is a electron, and gamma is just pure energy. Okay? So you want to see how these emissions behave in different black holes, right? So let's take a look at alpha, right? Already I have the notes. I want you to still write the examples in the book, right? So for example, alpha. Well, there's no example, but alpha is what? Alpha is a helium atom. Helium is 4,2 He with a charge of +2. Okay, so I'm going to write the whole note. I just want to write what alpha is. So write the symbol alpha. Alpha is equal to 4,2 helium. So every time you see 4,2 helium, that is the alpha particle. Okay, so 4,2 helium is the alpha particle. All right. Now, what happens? What happens when something undergoes alpha decay? So, right. If you look here, here we have a particle named radium. Right? Look at the mass number of radium. Radium is what? 22688, right? Yeah, 22688. So if radium undergoes alpha decay, once you'll see that symbol, that means alpha. Once it undergoes alpha decay, you'll see what happening. An alpha particle being produced, and the mass number dropping by 4, and the atomic number dropping by 2. You see that? Right? Watching good. It used to be 226. Now it's 226 minus 4, which is 222. Okay? The atomic number was 88. It lost a mass number, atomic number of 2. So it's now 86. Okay? So what you will learn in radiation is that whenever something undergoes alpha or beta or gamma, we have to balance the equations. In physics, balance simply means your mass number on the left-hand side must be equal to your mass numbers on your right-hand side. Are you okay with that? Yeah? So that is your alpha decay. Right? Mass number will drop by 4, atomic number will drop by 2. You don't have to write this one. I'm going to this now. You don't have to write this one. Right? I just wanted to write the important thing. So what important might be you lose a mass number 4 and an atomic number 2. Right? So you can just make a note of that. When something undergoes alpha decay, it loses a mass number 4 and atomic number 2. When something undergoes alpha decay, it loses a mass number of 4 and an atomic number 2. Right, when it finished, let's take a read of let's see what happens when you beta. Right. Take a little read now at the beta. Tell me what you'll recognize. What's different about the beta particle? And we're trying. Vishish, we're trying. Huh? It's so the mass number what? Staying the same or changing? Stay the same, and the atomic number what? Increasing by what? So make a note of that, right? Make a note of that. During a beta decay, the mass number stays unchanged. The mass number stays unchanged and the atomic number increases by 1. Right. Anybody else? Not in the WhatsApp group online? Online? Everybody here in the WhatsApp group? When I get to that, I'll send you an invite or something. Yeah, I'll send you an invite. I can see. Huh? 7992608. You write that dumb dumb. Someone fix it. Or invent stuff. No, you can't be funny. Properly, right? Take your time. Talk about. Writing properly. Right. And last one I want to read. Take a read at gamma. Take a read at gamma. Tell me what you notice about gamma. Take a little read at gamma. Tell me what you notice. 7 1. What is 6? After that is a 1. And after that, 2. All right, 2. All right, 2. Just tell me what it is. I'm going to do this. 5 and 6. Don't hear. Right. What you'll notice, Michael? What you notice there about gamma? It not changing. You recognize that? Nothing changing. And anybody can say why? Anybody? Annalie? Could you guess why? Why that happening? Why it is in behavior like that? Huh? Right? It's not particle, it's just energy alone. Right? So it's not going to affect the mass number, or it's not going to affect the atomic number. Right? It's just energy. So it's just going to be a particle with less energy, right? Now for the fun part, right? We'll do the test now, right? We'll come back here and talk about those things. Now for the exciting part. Now let's see if we could do something and balance our equations, right? We said gamma has no effects. Alpha will make the atomic number drop by 2 and the mass number by 4. And beta will do nothing, right? Sorry, beta will keep the mass number the same. Right? I just make it a these particles, right? These are not real particles. Right? So 921494, here's what it underwent. It underwent an alpha decay, and it's going to undergo a beta decay. Right? And it's going to become some particle named UL. I don't know what that is, right? Right. Before I attempt, Jenny, to work out the mass number and atomic number, right? Because it underwent an alpha and beta decay, what are the next two particles that should be here? Underwent an alpha decay. So what should be here? A helium. So a helium should be here. 4,2 helium. And because it underwent a beta decay, what should be here again? An electron. Right? Now the trick is to be able to balance it all. That will help you figure out what the new mass number is and what the new atomic number is. Okay? So here's what you're gonna do. The new mass number, the old mass number was 214. The new mass number will be 214 minus this, minus this. Right? I'll put minus 0, right? You just have you don't have to. The new atomic number is what? I write in the old one, and the new one will be 94 minus 2 minus 1. That's okay? And then you work it out. So your new particle will be UL. UL will be 210. And this is 93. Is okay with that? So that should be your balance equation. Not like chemistry, yeah? So physics, we only interested in the mass and the topic. That's okay? Copy it down. I'm going to give you one to try. Online, any questions? Online, any questions? Right, I will send my WhatsApp now. Anaya, could you send me a WhatsApp, please? For those who are online who not in the group, send me a WhatsApp now, please. Right, send my WhatsApp with your name and I will save it and I'll add it to the group one time, right? Right, I will remind you, but next week, right? Next week is online, 6 o'clock, 6 to half 9, right? You don't have to stay for the whole thing, but during that period is where I'm going to be by mechanics and thermal with past papers. Okay? If you want to come in person, you have 11 earlier. If you want to come and just stay till 9 o'clock. Right? That's you all night. No, you have 11 immediately, right? Like Monday or Tuesday later. Right? Even if I look at you or open. Was about 70 of them. I could put in new people, I just forward them back the handout, right? Yeah. I'm going to give me this one again, right? Give it out. Right, 95, 42. Again, I'm making these things up, right? They will give you actual particles, right? So we call this one CH. This one undergoing alpha decay, undergoing beta decay, and it undergoing gamma decay. All three. To become Ri, and I want you to finish it up for me. Finish the whole equation up, and then I'll make it more. I'll make it a little more complicated, slightly more complicated. Let's write symbols for gamma. And let's show you all the symbols, right? The symbols was alpha, beta, gamma. Ri. It don't matter. I just make it up, right? Okay, this is Chris for you. Okay. Right after next week, you go until 5:30, right? 5:30 to 5:30, right? After next week. Oh yeah, I'm balance it out. Tell me what you got. I have last minute. You go ahead, I'll joke it. Right, so what it should be the group. No. Sorry to do it again now, but you all can just delete it, right? So just send it back again. All right, let's go. So I'll make it a little bit harder, right? So we said alpha, we said 1 alpha. So that's 4, 2 helium. Gamma is just energy, electron is 0 minus 1 e. Right? So what would Ri be? Ri will be 4. Nothing here, right? So just leave it like that. We know what the symbol means. The symbol means energy. Right? So it will be 95 minus 4 minus 0. So that's 91. And then to be 42 minus 2, add back 1. So that's 41. Are we okay with that? Right? Try one more, a little bit harder. Right? Instead of me giving you 1 alpha, I'll tell you 2 alpha. So it means that you will have a 2 here. Right? You'll have a 2 here. So you have to, I want to see what you will do with the mass numbers and the atomic number, right? So let us go with a new particle. The particle is 52 ZA 21. Right? X, I mean X. Right? And it underwent, Stefan, it underwent 3 alpha decay. It underwent 3 alpha and it underwent 2 beta. I want you to complete it for me, please. VI and writing the 2 particles and balance it. You can balance it, right? Online, right? Online, you all could send me the mass number for VI and the atomic number for VI, right? Everybody up, please. Send the atomic number and the mass number. Right? Ready? Ready? So it's 3 alpha. So you put in 3 by 4, 2 helium. And the 2 by 0 minus 1 E. Right? Some people just put the 3 in front, some people put a little bracket so they don't mix it up. So it don't look like 34 or anything. Okay? So this tells you that it's 2 of these particles, 3 of these particles. All right? So this will affect the mass number by how much? 12. Right? This will affect the atomic number by 6. This will affect the mass number by 0. This will affect the atomic number by -1, right? So let's see. So let's see if online send anything. One person answer online. One person. Who's that? Teresa. Nice. Online, I want to get some more. Just message 2 values. Aliyah. Nice. Other connect. 14 something. Right. Nice job, Brigitte. Anybody else online? All right, so we can work it out. That would be 52 minus 3 by 4, that's 12. 2 by 0, that's 0. Here is 21 minus 3 by 2, that's 6, minus 2 by -1, right? So I put in minus 2 by -1 is minus. Right? So we're going to end up with 52 minus 12, which is 40. 16 minus that is 5, so that is sorry, that's 4, so that's 70. So the new particle is 4017 PI. Everybody okay with that? Yeah? Anybody confused? Online? Anybody confused? Right? I'm not getting answers from Anaya, Arissa, all over online, except for Richie, Chelsea, I didn't get any answers. Celine, Gerard, Chaya Marie, I didn't get any answers. Mark, Kezia. Don't forget to send your answers, please, Serena. Wait, where Anaya? Oh, Anaya, you're there. Oh, there's something I give. Everybody okay with that? So I'm going to go in reverse now, Taisha. Right? I'm going to try and go in reverse. So I'm going to give you the particle and you have to tell me what kind of decay it underwent. All right? So I'm going to go in reverse. Right? So let's say I gave you something like this. 40-20 calcium as an actual particle, right? It became 36. What's 36? I don't know now. I don't know why it's 36. Let me say that I repeat. Right? 19. Could you all tell me what type of decay this underwent? Think about it. It's a little tricky. I'll give you a hint. It's more than one. Try first. Right? See if we can figure out what type of decay it underwent. By the way, come on, both together video. Anyway, I really think that's something. I was going to spoil it. Yeah, kind of work in reverse. So you have to work in reverse, right? What type of key will give you 3619? What type of key will give you 3619? And it's more than one. More than one. More than one. Right? More than one, right? Something like this might be, that will be about 3 marks. That will be about 3 marks. Right, because they want to make sure it balanced and you have the two right things. That's 1 mark each. All right, let's see. So to balance this, you'll recognize that the mass number dropped by 4. Right? The only thing that could do that for you is beta. Sorry, is an alpha. So you know it have to have at least 1 alpha. But 20 minus 2 is not 19, it's 18. So we need something now that will not change the mass number, but increase this by 1. So it has to be a, right? 1 beta emission, right? So add them up, make sure it's 40, add them up, make sure it's 20. Everybody okay with that? So it's 1 alpha, 1 beta. You okay with that, Jenny? So we could also go in reverse, right? We could balance the equation or we can go in reverse. All right? All right. So I want to give you one table now with a little more information about alpha, beta, and gamma. Okay? So let's do a little table, 3 or 4 rows and about 6 columns. Part of it in the handout, but not the whole thing. What I mean, 1, 2, 3, 4 rules, and 6 column. 1, 2, 3, 4, 5. Huh? Yeah, we're just going across there. No, I don't. You have this space and you fill it up. Right, so I did the first one for you, right? Alpha. Alpha is a helium atom, charge +2. Beta is a electron, gamma is energy, right? We need to know these things here. How does it ionize? I'll explain what ionization is. How to stop it. How the penetrating power is. And how far it can travel in here. We need to know these things. Right, so let's do the little table. All right, ready? All right, so I want to explain the ionization power first, right? So just imagine this. Imagine you have these particles here, right? You have particles, and you have an alpha particle passing through here, and you have a beta particle passing through here. Which one bigger? Look at what they are. Alpha, right? Alpha at least 4 times bigger than beta, right? At least, but it's way bigger than that. So imagine that you have this big alpha particle with a charge of +2 and a small beta particle of a charge -1. Right? You know what I mean, right? Real small. You all know what ions mean? Ions are what? Chemistry people. Right, so something that has a charge, right? So atoms, no charge. Ions have a charge. So if I bring something, right, that is +2 close to something with no charge, what do you think might happen? It might cause the electrons in here to be attracted to this. Sort of, right? Because if something is +2 and have electrons, it might pull the electrons. Right? So basically, it's going to cause these neutral atoms to become ionized. You understand that? So ionized basically means something that's neutral become an ion. All right? So which one of these will cause greater ionization? Which one of these will cause a greater ionization? Alpha. You okay with that? So when they ask which of these, when they ask the ionization power, you're using high or low. So the ionization power of alpha is high. That makes sense? The alpha particles will make these neutral particles get charged way higher than this one here. So you would probably say beta is low. What you would say with gamma? Huh? Could gamma cause ionization? Has no charge, and gamma have no charge, so you can say none. All right. So ionization power, alpha is the highest, beta is the lowest. Sorry, but low, gamma has no effect. Okay? And ionization basically means the ability to turn something into ion, which is to give it a charge, right? Right? Nice. Alpha, beta, and gamma, they can be stopped by different materials. Right? If anybody read you handout for homework, you will see that we can stop alpha by using a few. Right, anyway, we can stop alpha. I'll put it right here. We can stop alpha by a sheet of paper. Right? So if I have an alpha source, watch this here. If I have an alpha source and I put paper here, that alpha cannot pass through this paper. Right? But beta will go through it. And gamma will go through it. Both of them will go through it. Right? So paper will stop alpha. How do we stop aluminum? I mean, how do we stop beta? Right? We use a few millimeters of aluminum. How do we stop gamma? Right? A few centimeters of lead. Okay? That's the way to stop each one of these, right? Right? So if you want to stop these radioactive particles, that's what you can do. Right? Put the right material in front of it. Right. Question. This question goes to Samir. Samir, based on what you're seeing here, right? Based on what you're seeing here, who has the highest penetrating power? Think of what you're seeing here, right? Who has the highest penetrating power? Very good. Right? Who has the lowest? And of course, beta is in between, right? Right? So you can see it here in this diagram earlier. And I sure if you all saw this, but on this diagram, right? This diagram shows you that gamma going through these two things, beta going through this, and alpha being stuck this. Right? Online, you're following so far. So this table here shows you, right, how alpha, beta, and gamma differ in these different properties here, right? Anaya, are you okay with this? Alia, Chaya Marie. That okay with us? Yeah. So it shows you how all them behave, right? Oh, they have this? Oh, they have this diagram here. Make a note underneath, please. Right? This diagram shows you what happened here. Right? Last thing here. How far does alpha travel in air? It travels a few centimeters. Beta travels a few meters. And gamma travels a few kilometers. Okay, this is how far they travel in air, right? So if you were to allow alpha to go in free air, it will travel a few centimeters before it stops. Beta will travel a few meters, and the gamma will travel a few kilometers. So which of these is the most dangerous radiation? Gamma. Right? So you see what gamma radiation can do. It can travel kilometers, and it's very penetrating. All right. Okay, so let's make a note of this, and I want to give all that homework for the window. Now, give all of that list one time. Right, I'm giving it this one time because I don't feel all over go man do it. I don't do it, yeah. All right. So at the end of the class today, you should be able to differentiate between these two radiations. Okay. All right. So watch this here. Last thing. Last thing I want you to pay attention to here is What would happen if you bring this radiation next to an electric field? Electric field means that one of the plates negative and one of the plates positive, and in between here there's an electric field. What will happen to alpha, gamma, and beta? Based on your little knowledge, right? What happens to a positive particle? Attracted to what? Negative, right? And a negative particle is attracted to. So alpha is what? Positive. So it will be attracted to what? Negative. Beta is a what? And negative. So it will be attracted to the positive. Gamma is what? Any charge? So what answer it? Yes. Very good. Right? Same thing here. Alpha will go up, beta will go down, gamma will go straight through. For now, you have to learn this because I have a rule to show you, Fleming's left hand rule, but we didn't do it as yet. All right? Right, so I want you to learn this. While you're drawing, I have one more question, and then we can leave. Why it is alpha going on a longer path than beta? Why it is these paths not exact? Right? Think about it, and then I will ask Said. Try that quick. Why it is alpha traveling a longer distance before it going upward? Right? So yeah, she said the alpha particles are heavier, which is true. The alpha particles are heavier, so they will travel a further distance. That's okay? So because it's heavier, it will take longer for the field to pull it in. Beta is light, so the pull it in real fast. That's okay? So next day, I'll add this on to Kahoot, and we will continue from there, right? Right? What we're moving on to now, the calculation part of this. So because I'm going to miss it next week, I'm going to send 2 videos. Next week, we're not continuing this, we're doing revision, right? So your class is from 6, I'll send that our message on the group. From 6 to 2.5 hours, half 8. Right? 6 to half 8. You don't really start 6 o'clock. Right? If you all want to come in person, you have a message because that class are about 70 people already. So I'm using in 2 rooms here. All right? All right, online. So I will send you